Welcome to part 2 of our series on deductive arguments. This part covers rules 22 to 26 from the textbook A Workbook for Arguments by David Morrow and Anthony Weston. These are basically logical forms that are valid deductively. Rule 22 is Modus Ponens. This is Latin for the mode or method of affirming. The logical form of a modus ponens argument is if P then Q, P therefore Q. It's called modus ponens because the first premise is a conditional, if P then Q. The second premise affirms the antecedent of that conditional. It says the antecedent P is true. And to the right, we have the logical symbols for the logical form. P horseshoe Q, P. Therefore, that symbol basically means it follows as a matter of truth entailment. It follows as a matter of valid deduction, that Q. So here's an ordinary language example. If a person is a washed out actor in his 50s, then he is legally permitted to drink alcohol. BoJack Horseman is a washed out actor in his 50s. Therefore, BoJack Horseman is legally permitted to drink alcohol. Modus ponens is one of the most common types of valid argument forms. One thing to keep in mind with modus ponens and the other argument forms is that the order of the premises does not matter. When we put the argument into standard form, it's customary to put premises first and conclusion last. So in general, we will do that. However, if you are reconstructing an argument, it's okay if you reverse the order of the premises. If the premises occur in reverse order in the argument, it can still count as the same argument form, as long as there's a premise that matches each one that's supposed to be there in the form. For example, you could have a modus ponens argument in which it begins, BoJack Horseman is a washed out actor in his 50s, and then continues, if a person is a washed out actor in his 50s, then he's legally permitted to drink alcohol. If the conclusion was the same, it would still count as a modus ponens argument. Another very common argument form is modus tollens, which is Latin for the method or mode of denying. The logical form is if P then Q, not Q, therefore not P. It's called the method of denying because the second premise negates or denies the consequent of the conditional if P then Q. So here is a natural language example. If a woman is engaged to be married, then she wears an engagement ring. Katy Perry does not wear an engagement ring. Therefore, Katy Perry is not engaged to be married. So remember, with all of these arguments, it doesn't really matter whether the propositions are actually true or false. The argument form is still valid even if it had a false premise or a false conclusion. The general point about validity is that if it's valid, and then if the premises are true, the conclusion must be true. So the validity guarantees that if the premises are true, then the conclusion must be true. However, the argument can still be valid even if it has a false premise, which means that it's possible for the conclusion to be false as well. Another logical form is hypothetical syllogism. This is an argument with the form if P then Q, if Q then R, therefore if P then R. So here's a natural language example. If you take a critical thinking course, then you're more likely to spot flaws in people's arguments. If you're more likely to spot flaws in people's arguments, then you're less likely to be duped by people trying to manipulate you. Therefore, if you take a critical thinking course, then you're less likely to be duped by people trying to manipulate you. The term hypothetical syllogism is a reference to hypothetical, which corresponds to the conditional proposition, the if P then Q, because this type of argument form has two premises, both of which are conditionals, and the conclusion also has the conditional or if then form. The term syllogism is from a Greek word meaning argument, so that's why it appears in the names of many logical argument forms. Disjunctive syllogism is an argument with the form P or Q, not P, therefore Q. So here's an example. Either you come to class or you must study the material on your own. You did not come to class, therefore you must study the material on your own. In addition to it being okay if the premises are reversed in order, there's another version of the disjunctive syllogism in which the second or additional premise negates the second disjunct. So at least for the purposes of this course, we will count both of those as following the disjunctive syllogism form. So for example, if this argument had been either you come to class or you must study on your own, you did not study on your own, therefore you come to class, it would still count as the same argument form. Dilemma, often called constructive dilemma, has the form P or Q, if P then R, if Q then S, therefore R or S. It's called the constructive dilemma because out of that disjunction in the first premise, you can create another disjunction in your conclusion. You can construct or create another disjunction. In this context, the term dilemma is referring to that disjunction. So here's an example. Either we become close to others or we stand apart. If we become close to others, then we suffer conflict and pain. If we stand apart, then we'll be lonely. Therefore, either we suffer conflict and pain or we'll be lonely. So this little argument is nicknamed the hedgehog's dilemma, in presumed reference to the fact that hedgehogs are covered in prickly spines. And so presumably when they get close to each other, they will cause each other pain by pricking each other. Although I've read that's actually false, that they're able to manipulate their quills so that doesn't happen. But whatever. It's a nice little illustration of the dilemma argument form. And as with the other ones, look out for this if the premises are in reverse order. There are 3 premises in this argument instead of 2 in the previous forms that we looked at. So that's another way of recognizing it. It's also the only argument form you'll be learning that has a disjunction or statement both as a premise and as a conclusion. So those are not by any means the only valid logical argument forms. There are some of the common ones. We'll be learning another type of valid argument form called the reductio ad absurdum in a later video. But because those are the common ones, it's enough for our purposes to give you an introduction to deductive arguments. One of the things that comes up a lot when trying to analyze and evaluate arguments is the wording of the argument in English or another natural language can make the structure less clear to see. So there are some techniques you can use that will help highlight or bring out the logical structure of an argument. So it's in general helpful to translate an argument from English or another natural language to logical symbols. If you're doing that, the first step can be to circle the logical operators, the logical connectives in the argument. The words or, if, then, or not. There can be cases in which these words are used non-truth functionally, where they're not used as logical connectives or logical operators, but most often they will be. There can also be cases in which you may have an if-then claim that just happens to not be a part of the main argument you're looking at. So there's lots of wrinkles in interpretation. We'll be covering some sample arguments that will help iron out some of those. After you've circled the logical connectives, you should underline the simple propositions. Or you can use some other notation too. Actually, in these videos, I'm going to be putting text into color or bold to help illustrate the structure. But if you're doing this by hand on paper, it can be helpful to circle the connectives and underline the simple propositions. Now, something to be on the lookout for is that there can be parts of a passage of writing or speech that is not part of the logical argument. That could be before the argument, in the middle of it, or after. That might be providing context, information, some type of emphasis. So be on the lookout for propositions or parts of sentences that are parts of the argument and those that are not. Also, be on the lookout for cases in which the same proposition, the same claim, is made using different words. So both in speech and writing for natural languages, it's common to vary the wording of a proposition for the sake of variety and other reasons too. However, in logic, we need to be able to recognize that it is indeed the same proposition that's being repeated. So look for the meaning of the proposition. If it means the same thing, it's the same proposition, and you should translate it using the same capital letter. And then after you've done circling the logical connectives, underlining the propositions, you can also do a separate step, which is to write it out just in the simplified logical form. And after you've done that, you can check to see if the form of the argument fits any of the valid argument forms that you're learning. And as I mentioned, there are other types of valid argument forms. There's an infinite number, logically speaking, but there's a larger number too that are commonly named and discussed. Nevertheless, the ones that we're covering are some of the most common ones. So let's look at a sample problem to illustrate how this is done. We're starting with an argument in natural language, and we're trying to figure out what its deductive argument form is, what its logical form is. If I bet red on roulette, then I will win my bet. If I win my bet, then I will stop betting. So if I bet red on roulette, then I will stop betting. To begin with, we're actually going to look for the conclusion. This was not something I mentioned explicitly in the previous slides, but you can also do it as a separate step to help clarify the structure of the argument for you. The conclusion may have indicator words like therefore or thus to indicate it. So can you spot the conclusion in this case? In this case, the word so is functioning as a conclusion indicator word. There can be other cases where there's no specific indicator word, in which case you just have to understand what the argument is doing logically to identify the conclusion. Which proposition is being proven by the others? That is the conclusion. Our next step will be to circle, or in this case, highlight the logical operator terms. So we're looking for terms like if, or, and, not. We can see that we have three instances of if. If is often paired with then. Remember that when you see if and then together, they're going to be translated using one operator if you're using the symbols, the horseshoe for the conditional. Also remember that with any of the operators, it's possible for the wording to vary. As we go through this series of videos on deductive arguments, we'll give different examples of how the wording can vary for the different types of operators. So you see we have three instances of if-then, or three conditional propositions. You might be able to guess the logical form of the argument already just based on that pattern. But first, let's identify the simple propositions in this argument. Those are the ones that are being connected by the logical operators. The first simple proposition that we see is I bet red on roulette. I'm using a different color to highlight it so that we can tell it apart both from the operators and from the other simple propositions. You'll notice that in this case, the proposition is repeated with the exact same wording later on in the argument. That makes it easy for us to identify where it pops up again. Remember that sometimes you'll have to figure out when the wording changes if it's referring to the same proposition or not. However, there are other simple propositions in this argument. Another one is I will win my bet. And you can see this proposition is also repeated once in the argument. And finally, we have I will stop betting. So at this point, we've identified the conclusion. We've identified three logical operators, if then, and we've identified three simple propositions. So now we can put our argument into a simplified notation. This is the one favored by the textbook, A Workbook for Arguments, where we're using the English terms if and then to express the operators, but we have capital letters to symbolize the simple propositions. I've also put the conclusion indicator word therefore in bold. Now let's also put the purely logical notation for comparison. So I've also numbered the premises and the conclusion here. You may wish to do that when you're analyzing an argument, just to remind yourself of the number of premises you have, because that can also be a clue for the argument form. And as we'll see later on, there can be arguments that have multiple steps as well. Now, can you recognize the logical form of this argument? It is hypothetical syllogism. The main clue is that we have the same logical operator, the if-then or the horseshoe, appear in both premises and the conclusion. That only happens in one logical form. Now let's look at a second sample problem. Credit card fees continue to go up. If credit card fees continue to go up, then customers will stop making payments on their cards. It follows that customers will stop making payments on their cards. Let's begin by looking for the conclusion of this argument. The phrase "it follows that" is indicating the conclusion. Now, it's not the most common conclusion indicator, but it does happen. The most common are probably therefore, thus, and so, but you can get these phrases as well. Now that we've identified the conclusion, can you find the logical operators in this argument? We can see one logical operator, if, then. There do not appear to be any other logical operator terms. No ors, no nots, no ands. So the next step is to identify our first simple proposition that appears in the argument. Its credit card fees continue to go up. This simple proposition is then repeated in the antecedent in the conditional that follows. Now let's try to identify another simple proposition. Its customers will stop making payments on their cards. And you can see that also is repeated once in the conclusion. So putting this together, let's rewrite the structure of the argument just in its logical form. C, if C then S, and S. And you can choose any capital letter you want to stand for any proposition, any simple proposition. It's customary to choose a letter that will remind you of one of the main terms in that proposition. So you can see here, and in some previous slides, we've done that. The C stands for credit card fees continue to go up. S stands for customers will stop making payments, and that's it. So do you recognize the logical form of the argument? It may help to put it in symbols if you're still not sure. Now remember, the key thing here that may be tripping you up is that the order of the premises can be reversed. So what is the logical form of this argument? It's modus ponens. When I gave you the definition of modus ponens, the conditional was first and the antecedent premise was second, but the order can be reversed and it still fits the same logical form. Because one of the premises is a conditional and if-then, the other premise affirms the antecedent of that conditional, and then the conclusion is the consequent of that conditional. So that's a modus ponens argument even if the order of the premises is reversed.